Once again, we've reached the fun part where we get to have a look at our data, see what it looks like, and in particular see whether it looks anything like the data from Alan Kohler on the ABC. So, first thing we want to do, we've collected up the GDP percentage changes per capita. First thing we'll do is we'll put those into an array. So let's call that GDPs. And we'll just put in GDP changes. Okay, so that's our GDPs, which will be the values in the y-axis on our graph. The next thing is the values on the x-axis. Now, you recall that the dates that we had from the CSV file looked like this. So they're not numerical dates, and we could plot against these dates just by using an index. So we're plotting against 0, 1, 2, 3, 4, effectively the index of those. But so that we can actually see what year and what quarter is on that axis and plot against that, what we're going to do is generate our own dates. We've seen a few different ways of doing dates, but what we'll do is, just because we've just got quarters, we'll just generate a range. Okay, going from 1973.75, which is the third quarter, through to 2020.25 in increments of 0.25. Okay, so we're just going to have the year and then the fraction of the year. So it's pretty much the same as what we did with the 12 months, when we had each of the 12 months as 1/12. But in this case there's only 4 of them. So let's just see what that looks like. Okay, so that's what we expect. We go through from the third quarter 1973, or sorry, the fourth quarter, because we're starting from 0. So 1974.0 is the first, what we're calling the first quarter. Second quarter, third quarter, fourth quarter. Okay, through to the March quarter of 2020, so the first quarter of 2020. Okay, so we can now plot that and see what it looks like. So let's just add another cell, and we'll use our plot function again, and we're just going to plot the dates against the GDPs. Okay, so far it's not looking a lot like the ABC plot. Before we go on, let's just to make this a bit clear, we used one of these, this is one of the backgrounds that Seaborn uses, and the reason it's designed this way is so that you can see the lines here, but they're pretty unobtrusive. Compared with if you have a white background and you have black lines, for example, which is commonly the case, it's quite intrusive. So this is kind of a way of just subtly seeing those lines in that style that we chose. However, it doesn't really distinguish our 0 or our x-axis from everything else. So let's put that in ourselves, just so that we can see it as a plot against the axes. So again, we'll plot against the dates. So that's the x-axis, and the y-axis we just want zeros. So we know how to get zeros. We can use zeros like, and we'll do it like GDPs, so it's the same size, and then we'll make that one grey. I always forget whether grey is G-R-E-Y or G-R-A-Y, because both actually appear within Matplotlib. Okay, so there's our values against the 0 axis, just like we've got here. They don't look a lot like Alan Kohler's values. So the first thing we want to do, so we've plotted all the data here through from 1973, but Alan Kohler's graph only goes from, we can't tell exactly because there's no tick marks on the axis, which is not very helpful. Again, not good practice if you're producing the graphs. But we know it's round about 1995, so let's just use masking to plot those dates. So let's make up a mask, and we'll get all the dates greater than or equal to 1995, and this is why we used numerical values for the dates. It makes it easy to do this kind of thing. And then let's just do our plot again, except this time we'll mask the values. So let's mask that one. Okay, so we've now got just the dates from 1995 onwards. It's starting to look a little bit more like this data, but still not a whole lot. You might be able to see a bit of that trend in there. Before we go on, what we might do is just put in so all I've done here is I've just given those dates and that set of dates and GDPs a name so that we can use them again, and simplified this a bit here. So let's just run that off again to make sure that we haven't made a mistake. Okay, so our data still doesn't look like this data here, so we think we've got the right data from the ABS, and we might ask ourselves why that is. And there's a bit of a clue up the top here, where it says annual % change, which suggests to us that these are actually annualized data. So what we've plotted here is the data for every quarter. The annualized data is the data for the year, but this is not the data. It's not the data for the year in the sense of all the data for 1995 and then all the data for 1996 or all the data for 1997, etc., or even for the financial year. What it is at this point in time, what does the last year look like? At the next quarter, what does the last year look like? So we're going to annualize the data and see how we compare. And to do that, we're going to introduce two-dimensional arrays, and we'll show how it's handy for this task. We could, of course, in order to annualize the data, so effectively we need to, for each quarter, we need to add up all the data for the previous, or for the 4 quarters up to that point. So we could go through with some loops and, nested loop or something like that and add them up. But as usual, if we've got array data, we can do it far more clearly and efficiently using arrays. If we have a look at the code here, so this is actually a bit like, we've done something a bit like this before. You remember that when we were doing the histogram and we wanted to get the bins in the histogram, we had to find the midpoints of those bins. And the way we did that was we took all the, we had the edges of the bins returned from our histogram function, and we took all the edge values and then we shifted them all across, and then we added them and divided by 2, so we just averaged them. So effectively what we were doing was we were averaging the left side of the bin and the right side of the bin in order to get the center value, but we're doing that with one array operation rather than doing it with loops. So we're going to do a similar sort of thing here, except now we've got 4 quarters, so we want to sum up over those 4 quarters. So what we're going to do, and it's a bit easier to see if I actually put the output up here. So the first thing we need to do is set up an array of the right size. So we're going to want an array that's as wide as all the GDP values that we have, but we're going to add 4 things together. So we want it to be 4 high and the size of the GDPs wide. So we already know how we can set up an array. We've done it before with one-dimensional arrays using something like numpy.zeros. In this case we use a pair, and have a look at the documentation. It's important to remember that you need a tuple in here, not just the separate arguments. So here we have a 2-dimensional array. NumPy can do multi-dimensional arrays, and we specify that with a pair. So the 4 here is the height of the array, and the length of GDPs is the width of that array. So we've set out our array of zeros, and the next thing we're going to do is start filling it in. So the first line of that array, the first row, is going to be our GDP values. If we do shifts naught, that's actually shorthand for shifts naught, comma, everything. So shifts naught will just give you that first row, and I'll come back to why it's the row and not the column once we look at axes. So the next thing we want to do is shift everything to the right one place, because we're going to ultimately add them together. So shifts, so 1 here is the row number, so that tells us we're in this row 0, 1. Okay, and the second argument here is the column. So these are selection, just the same way we've done selection on 1D arrays, and we did it on lists and so forth. So this tells us that row 1 from column 1 to the end, okay, so that's this part here, from 1 to the end, is going to be equal to GDPs from the start up to -1. Okay, so we've got to make sure it's the same size. What we're putting is the same size. So the size we've got here is from 1 to the end, so we're missing out the first one, and here we're missing out the last one. So what we're doing is we're taking these ones here and we're putting them in one place further to the right, and then we're going to keep doing that. So the next one we want to shift it 2 places to the right, so we need to get out, we can only fit in here 8, well, I'm just printing the first 10 here as an example. It's a much longer array. But with this example, the first 10, we get the first 8 here. So everything except for the last 2. And then we're going to put it in here in the second position. So this tells you everything except for the last 2. Everything up to -2. And we're going to put it in the second row, and from the second column onwards, 0, 1, 2, third column, 0, 1, 2 onwards. Okay, and then the next one we're going to shift it one place further right again. So we're going to get out, in this case it's the first 7 of those, so we're missing out the last 3. So we've got GDPs from the start up to -3. And then we're going to put them in from column 3 up to the end. Okay, column 3. So in row 3, we're going to put them from column 3 up until the end. Yep. Okay, so row 1, this one here, is going to be everything but the last one shifted 1 to the right. Row 2 is everything but the last 2 shifted 2 to the right. Similarly, row 3, 3 to the right. Okay, so now if we want to get the sum of the last 4 numbers, all we need to do is sum down these columns. So how do we go about summing down those columns? And if we have a look at the documentation for sum, we'll see that sum allows you to specify which axes it works in on a multi-dimensional array. And there are many methods that actually do this, so it's worth trying to get our heads around. So sum, numpy.sum, if we just have a one-dimensional array, it will just add up the whole thing. If we have a multi-dimensional array and we don't specify which axis we want to add up over, then it will add up all of them. So effectively it will convert it into a big long one-dimensional array and add it all up. Okay, but what we can do is specify the axis along which the sum is performed. So if we go back to our array, okay, the columns here, so the axis is either, it's a bit like a Cartesian axis in a sense. So we've got one axis that goes across the rows. We've got one axis that goes down the columns here. And we can easily find out which is which just by running an example. So here what we're going to do is we're going to specify an array that's short and wide. Let's print that, and then we'll ask NumPy for the shape. So any array, you can always call the attribute shape. Remember, it's an attribute, not a method, so there's no parentheses there. And shape will give us the shape of that array. It's an incredibly useful thing to remember. So here we've done our short and wide array, and we've cast it from a list of lists. And what it does is it uses that first list as the first row, the next one as the next row, and so forth. So the array that we end up with looks like this. And if we ask for the shape, it's 2 by 5, so 2 rows and 5 columns. Okay, if we now ask it to sum over axis, let's just start with axis 0, and let's ask it to sum and see what we end up with. Okay, so you can see that what we've ended up with is the sum down these columns. Okay, so 1 and 6 is 7, 2 and 7 is 9, and so forth. Okay, if we ask instead for it to sum over axis 1, you've guessed it, we end up with the sum of the rows. Okay, so 1 up to 5 is 15, 6 up to 10 adds up to 40. Okay, so one way to remember that is that the axes are numbered a bit like binary numbers or decimal numbers, where you get sort of more significant figures as you go to the left. So this is the 0th one, this is the first one. Okay, so the 0th one is summing the 5 columns. Number 1 is summing the rows. Okay, so you can sort of think of the columns as being subsidiary to the rows, perhaps. Let's just check that by turning it up the other way and see if we get what we expect. So this notation, the dot T here, stands for transpose, and so that transposes the array, which means that it reflects it on the diagonal. So if it started off as an array that's sort of long and shallow, you reflect it on the diagonal, so reflecting across the diagonal, then it's going to be deep and not very wide. Yeah, maybe it's better to, that's more indicative. So if we reflect it on this angle here, then it goes down like that. Okay, so here's our array. So now it's going down like this, and if we sum it now over 0, which remember was the columns, okay, we end up with so firstly this is the shape 5 by 2 rather than 2 by 5, so 5 rows 2 columns. 0 sums down the columns, gets 15 and 40. 1 will sum across the rows, and that gives us 7, 9, 11, etc. Okay, so let's use that to sum up our actual shifted GDPs. So let's just take a copy of that and paste that in. Okay, so we're going to do what we did before, but now we're going to want to sum up all those shifted rows. So let's call that annualized. Okay, so shifts is the name of our array, and we're going to sum. Now remember, we want to sum down these columns, so we're going to sum across the 0th axis, and then let's just print out the first 10 of those. Okay, so let's just do a sanity check on our work. So we've printed out our shifted values in our 4 by n array. If we sum down the columns, we've got 2.1 minus 0.4 plus 2.1 is 1.7, etc. Okay, so it rings true. We've just printed out the first 10, but of course we've done this for the entire array of GDPs, not just for the first 10. So we've done that all the way up to March 2020, and now we can plot our new annualized figures and see what we get. And bingo! So this is our annualized data. Okay, this is Alan Kohler's graph, and this is the graph that we got out of that from the CBA, Commonwealth Bank of Australia report from that magazine, and you can see that they're the same. This one doesn't have the final point here because it was taken before that last quarter, but you can see that that they're the same. This is the ABC's terribly stylized graph, but it's close enough that you can see that it's showing the same data here. Okay, so far so good. Next we want to have a look at this dashed trend line. So we'll look at putting in a trend line ourselves. So that will be the next section.